find something I wish I had put on the notes here. What am I doing here? Okay. Before we even get into factoring, I need you guys to remind me how to multiply two binomials. So like let's say I have x plus 7, x minus 10, like that. Okay, so how do I multiply these two things together for that? Anybody remember how to do that? You might have been taught, they might call it a rainbow method, like you're going to, basically you distribute here. Some of you might have used a box for this, where you have like x plus 7 on top and x minus 10 on the side. But x times x, what does that give us? X squared. X times negative 10, negative 10x. We can't really put them together, so we just write them multiplied together like that. So then we would, so once we distribute that, let me switch colors so it's clear what we're doing here. Then once you distribute that x to both of these, you also have to distribute the 7. So 7 times x would give us 7x, and 7 times negative 10 would give us negative 70. And then we can combine some like terms there. So these middle two terms right there are like terms, so we could put those together. So we would get x squared minus 3x minus 70. So it's important that we know how to multiply them back so that we can check our work. Here I'm going to show you a few different options for checking your work for that. So when we multiply, what kids do wrong on that a lot of times, if I've got x plus 7 times x minus 10, they say x squared minus 70. Right? So they don't distribute, that would be incorrect. They don't distribute both the x and the 7. Both the x and the 7 have to get distributed. You may have seen that with a box like this where you got x and a 7, x and a negative 10, and you do x times x is x squared, 7x here, negative 10x, and negative 70. You may have done it that way. Notice those numbers are the same numbers I got over here. Then you combine your like terms. Again, I do not care how you do any of this as long as you can do it correctly for that. So, factoring is the opposite of multiplying those back together, right? So we are breaking them back apart is what we're doing for those. So, the first thing we're going to start with is the greatest common factor, okay? So, the greatest common factor is going to be the biggest thing or biggest term you can divide everything by, okay? So, it is a term that goes into every term. There. So, for this, we are going to look for both a number and a variable, if possible, that will go into every one of these. Okay? So, if I look at example 1, if I'm looking at the big numbers first, anybody know the name for those big numbers, this big 3, the big 6, and the big 12? They have a name. Starts with a C. Well, I might have heard it. Somebody might have whispered it under the breath. Starts with a C. Do you know what it is, Zoe? No? No, it's not that. I mean, that's sort of like what we're, it's related to what we're doing, but it's not what you call those numbers, right? No. These 3 numbers right here are called coefficients. A coefficient is just the big number that's being multiplied by a variable. Okay, so a coefficient. So if I look at these 3 coefficients right here, they're just the big numbers, right? What number could I divide all 3 of those by evenly? 3. All right, so I want to divide all 3 of these by a 3. Then I want to look at the variables. And I want to see if I could pull out any of those variables. So in order for you to factor out a variable, every term has to have a variable. So like here, I'm going to be able to factor something out. What about number 3? Am I going to be able to factor a variable out of number 3? No, because 10 doesn't have a variable with it. So I can't take it out. So you want to take away the least number of x's that you have. Okay? So I got 3 x's right here. I got 2 x's right here. How many x's do I have on this last one? Just 1. It doesn't have an exponent there, but it's just 1. So you want to take away the least number of x's, so I could take away just 1 x. Okay. So when you're doing a greatest common factor, you need whatever you are coming up with to multiply back to give you what you started with. So you're going to have that 3x has to be written out front. Okay? And then you just divide. So when I divide 3 divided by 3, I get 1. When I have x to the third divided by x, what do I get? No, not quite. X to the second power. Because the way that works is you've got x to the third over x, which is you got 3 x's on top and 1 on bottom, so one of those cancels out, and you get x squared. You just subtract from the exponents is all you do, so it takes one of those away. All right, here, 6 divided by 3 is 2. I had 2 x's, I took 1 away, so I'm just left with a single x. And then 12 divided by 3 is 4. And there's not going to be an x here because you had 1, you took it away, so it's gone altogether. Is it necessary for me to write this 1 right here? It's not. In fact, you're going to look a little bit smarter if you just write it this way, 3x times x squared minus 2x plus 4, because it's usually not written, but if you put it there, it's mathematically correct, so it's fine with me. Okay, now, right now we're just doing greatest common factor. We'll worry about whether or not that factors further later, okay? Now, if I look at 2, what number could I divide all of my coefficients, my big numbers, by? Okay, 1 is the only thing, right? Because some of you may have been thinking like 4 or 2 maybe, but this first thing, does it have a coefficient? It does not. So that means it's got a 1 right there in front of it. And you can't, divide it by 4 or 8, not evenly anyway. So you can divide by, you can put a 1 there if you want, but is dividing by 1 going to change anything? No, it doesn't. Any number divided by 1 is still itself. So it doesn't really help to factor out a 1. But I do need to look at the variables also. So for this, I've got 4 x's here. I got 3 x's here. How many x's do I have at the end? Just 1, right? So I could pull an x out. So I would just be taking out a single x. I'm dividing everything by x, which just reduces the number of x's you have by 1. So I'll have x to the third minus 8x squared plus 12. Okay, everybody good there? All right, for 3, Hector, what number could I divide both of those coefficients by, both of those big numbers by? 5. Can I take an x out? I cannot, because 10 doesn't have an x at all. So only thing I can divide by here is 5. So when I divide by 5, I got to make sure I write it out front. And then 10 divided by 5 is 2. 15 divided by 5 is 3. Leave the x squared right there with it. Okay, Joey, how about number 4? What could I divide each of those terms by? Okay, 4. For the coefficients, 4 is the biggest number that will work. 2 works, but it's not the biggest number. You want to take the biggest number that'll work. And how about variables? How many x's could I take out, Joey? Okay, 2, because you want to take the lowest number, right? So you got x to the 6th, x to the 3rd, and x squared. So you're going to take out 2 because it's the lowest number. So we're going to have a 4x squared pulled out front. And then I've got 16 divided by 4 is going to give me 4. Joey, if I had 6 x's and I took 2 of them out, how many do I have left? On this first one, if I have 6 x's and I take 2 of them out, how many do I have left? 4. We've got 4 right there. We're going to have 8 divided by 4 is 2. We're just going to have 1 x left here. Now, this is kind of tricky for kids. What do I get for that last term? I get 1. I do not get 0. Sometimes kids want to cancel everything out because they do cancel there and put a 0, but 4 divided by 4 is 1, so those cancel to 1, not to 0. So, and if you don't have the 1, you can't multiply it back to get the same thing. Now, Desmos will not factor for you, but Desmos can at least make sure you didn't make a huge mistake. So when you have to know how to factor on your own. Desmos can't do it for you, but you kind of can check your answer, because like if I do 16x to the 6th minus 8x to the 3rd plus 4x squared, and then I go down to the next line and I do 4x squared times 4x to the 4th minus 2x plus 1. What I should see there is the graphs should be the exact same. They should be right on top of each other. So like if I did something wrong, like for example left off that plus 1, the graphs would not match. And that would tell me, oh, I've messed up somewhere. So it won't do it for you, but it will help you check to make sure you didn't make a major mistake there for Desmos. Okay, questions there? All right, so that is called the greatest common factor. A lot of times it'll be abbreviated as GCF. It is the first thing you want to look for every time you do a problem. Okay. Let's talk about how to factor the remaining binomial or trinomial. Okay. So whenever you want to do GCF first every time. So if there's a GCF, you're going to pull that out. On example 5, there is no GCF because this has a 1 in front of it. This doesn't have an X. There's no GCF on number 5. So if we have a trinomial, and how many terms does a trinomial have? It's got 3 terms. Then we want to break this down into 2 sets of parentheses. We're factoring it into 2 binomials. Okay, so whenever you were doing this, you probably learned this with the X method if you were around here, but if you didn't, you may have learned something different. Same process, really, just different tricks. So you want to multiply to get the last number, which is a positive 14. You want to add together to get the middle number, which is negative 9. Okay. So you can go through and think of the possibilities here. So to get positive 14, I could multiply 2 times 7. I could multiply 1 times 14. That's pretty much my only options, right? Nothing else works for that. But will either one of those give me negative 9? They will not. So I said it was pretty much my only options. This is my only numbers I could use to get 14. But what else could I multiply together to get a positive 14? I could do both of them negative. Negative 2 times negative 7, or negative 1 times negative 14. Those both give me positive 14 as well, right? I could have, because, you know, the better you get at this, I could have said, oh, well, it's got to be negatives because I got a negative in the middle, right? So both have to be negative, and I wouldn't have even worried about thinking about the positives for that. Do any of these now add up to give us negative 9? So that is negative 2 and negative 7. So negative 2 and negative 7. Now, if you're using X method, and I'm going to do this step just because if you're using X method, you have to look at the number that you got in front of this, right? And what it really should have done, probably, you got to do 1 times 14 to get the number that goes right here, all right? So at the end, you divide by that 1, but does it make a difference when it's a 1? It does not, right? So you're going to have x minus 2 and x minus 7 for that. Okay, so this right here would be our answer. We got a couple ways we can check it. The first thing you could try is just Desmos. So you could type in x to the second minus 9x plus 14 and x minus 2, x minus 7. You should get the exact same graph if you do that. So there's the black graph. If I click up here, it turns purple. That shows me, oh yeah, those are the same graph. If you had messed up, like say that was a plus 7, oh, they wouldn't match, you'd need to try again. All right. Now, this doesn't guarantee you factored completely because there could be like another step you have to do, but it does at least tell you didn't mess up badly. The other option for checking this is just to multiply it back together like we did before. So if I wanted to do that to check, I could, I'm just going to do this over here. I could do x minus 2 times x minus 7. X times x is x squared. That gives me negative 7x, negative 2x, and positive 14. And that gives me x squared minus 9x plus 14. So that one works. I'm not super crazy about X method on these, but I feel like it's the way most of you learn. So I'm going to show you X method first, then I'm going to show you what I would do, just for those of you that may want another option. So, so when we have a number in front of our X squared, whenever this number right here that can't be factored out as a GCF, that's going to make it harder to factor, quite a bit harder to factor. So when we have a number right here, first thing we want to do is look for a GCF. Okay, we want to look for something we can divide all of these by. Do we have a GCF? We do not. There's nothing you could divide all three of those by, so there's no GCF. So if you do X method, okay, you've got to multiply. Oh gosh, what's happening to my pen? There we go. You've got to multiply the 3 and the negative 8 to get the top number in your X. So you want to multiply to get negative 24. And then you still want to add to get the middle number, negative 2. So we would be thinking about the numbers we could multiply to get negative 24. There's a lot of options for this. I could do negative 1 and 24. I could do negative 2 and 12. I could do negative 3 and 8. See, this is where you got to know those multiplication tables. This needs to come to your head. I don't care if you use the calculator, but if you're having to, like, divide, this takes forever, right? Negative 4 and 6. And then I could switch the signs on those. So I could have positive 1, negative 24, positive 2, negative 12, positive 3, negative 8, or positive 4, negative 6. Now, the better you get at this, you won't list these out. To be very clear what I'm thinking in my head, I'm writing everything down for you guys. But, you know, the better that you are at this, you know, I can look at these and factor them in my head without writing anything down except for the answer. So the better you get at these, the less you'll have to write. But here, I'm looking for one of these that will add together to give me negative 2. Which one of these will add together to give me negative 2? Which one, Zoe? 4 and negative 6, right? So I'm going to put my 4 here and my negative 6 here. Now, this is different because you got that 3 out front. So you've got to take that 3 and you've got to divide by that 3. And if it will reduce, you want to reduce it. And if it will not, you have to write it differently. This is the part I don't love because this is just not all that mathematically sound. It works, but it's a trick. I don't think kids understand what they're doing exactly. So this is negative 2 right here. This one doesn't reduce, right? So so the x goes on the bottom. So you've got this first one will be 3x plus 4. And the second one will be x minus 2. Okay? And then if we want to check to see if that is correct, we could multiply it back, or we could graph it for that. I'm going to multiply it back. So if I multiply this back, 3x plus 4, x minus 2, I got 3x squared minus 6x plus 4x minus 8. So 3x squared minus 2x minus 8. And that is what I started with, so this is my answer. All right, now, like I said, I don't love X method on this. I don't mind it. If it works for you, that's fine. I got a few of you in here with super high grades, like high enough that I'll recommend you for pre-cal next time if you want to take it. So if you want to be in there with Hector in pre-cal, then in pre-cal, I start to expect you to be able to do this sort of just by guessing and checking. So what I do for this is the way I do it. I know to multiply this back to get 3x squared, I have to have a 3x and an x. I also know to get a negative 8, I could have a negative 4 and 2, or a negative 8 and 1, or I could switch the signs, right? So I just kind of guess and check what's going to work here, knowing that I need to get a negative 2 in the middle whenever I multiply it back. So, for example, I might try a positive 2, negative 4. And then I know the first is going to work. 3x times x gives me 3x squared. I know the last is going to work. Positive 2 and negative 4 gives me negative 8. So I just need to check the middle. That's 2x. That's negative 12x. If I put those together, do I get negative 2? I do not. This one doesn't work, right? So then I would switch it around, and I forgot that I don't have an eraser on this, so that's frustrating. And I'm also out of room. But I might want to switch where the 4 and the 2 are at. So then I would think 3x minus 4x plus 2. When I do this, I get negative 4x. I get positive 6x. That almost works because I get a positive 2. So then I could switch it and make this 4 positive and the 2 negative. But I usually do that in my head mostly. I don't actually write down a lot of that. So that's a thing to work towards. The more you can do this in your head, the better. But only if you're getting it right. If you're getting them wrong, just do X method. Do whatever works best for you, okay? For that. So, now, we sometimes get these, and they're weird. We got x squared minus 25. Does that have a greatest common factor? It does not. So, what you need to think of when you see this, and this is only when you're missing the middle term, okay? So we don't have Like usually it's x squared, x, and then a term without an x at all. So if you're missing the middle term, think of it this way. X squared plus 0x minus 25. Okay, so if we are thinking about this, we need numbers that can multiply to give us negative 25 and add to give us 0. Okay, so for negative 25, you could use negative 1 and 25. You could use negative 5 and 5. You could use positive 1 and negative 25. They're positive 5 and negative 5. That's not really different there. I think those are our only options. Which one works? Positive and negative of 5, right? That's the one that always works for these type of problems, right? The only way you're going to get 0 is to have positive and negative of the same number. So it's the one that always works, which makes these a little bit easier. So we got a positive 5, a negative 5, so we end up with the answer of x plus 5, x minus 5 there. Okay, now, when I see this one, I immediately know x plus 5, x minus 5, because it's always, this number right here is a perfect square. It's a number multiplied by itself. So it's always the positive and negative of that same number. Okay. These are fairly common, so there's a special name for these. They are called a difference of squares. So again, like if you're headed beyond, the faster and quicker you are with this, the better. Because like in calculus, we've been doing a lot of things where we got to factor and cancel for limits. Sometimes these problems take up half a page. This is just a teeny tiny step, right? So like if I have something like x squared minus 81, then the quicker you can do it, the better. What is that one going to be? Negative 9, positive 9. X minus 9, x plus 9. Because negative 9 plus 9 will give you 0 in the middle. Negative 9 times positive 9 gives you negative 81. Okay? So those are some of the easier ones, but sometimes they throw kids off because they're not the same as the others. All right, questions? All right, so let's look at a few examples together. So these are going to say factor completely, and that means you got to break it down as far as it will go. Earlier I said the first thing we always look for, what was it? Greatest common factor, every time. Does 7 have a greatest common factor? It does. So Cannon, what number could I divide all those by? 2. Can I take any x's out on this one? How many? 2. I can take 2 because that's my lowest exponent there. So I'm going to take a 2x squared out. Make sure you write it up here. A lot of times kids forget to write it here. So this is going to give you just 2 divided by 2 is just 1. And then you'll have an x squared. You can write the 1 here if you want, but you don't have to. We got plus 8x minus 9. Okay? So, earlier we just did greatest common factors and we didn't really pay attention to what we had left. But x squared plus 9x minus 9 might factor. We need to think about that, right? So, I want to think x method here. I need to multiply to get negative 9. I need to add together to get positive 8. Okay, so to get negative 9, you don't have a lot of options for negative 9. Negative 9 times 1, negative 3 times 3, or positive 9 times negative 1. Those are your only options, right? Will one of those give us a positive 8? Okay, that last one, all right? So that'll give us a positive 8. So 9 plus negative 1 would give us positive 8. So we want to think here, when we're factoring this 2x squared is just staying out front. So we're not dividing stuff by 2 here for x method because we had already factored that out. And in front of this x squared, we just have a 1. So we don't really have to divide anything off. But don't forget to write your 2x squared. It stays here. And we'll have x plus 9, x minus 1. I highly suggest on these, at least on a quiz or a test, that you, and we'll have a quiz on Friday, that you type this in, 2x to the 4th plus 16x to the 3rd minus 18x squared, and then type in your answer, 2x squared times x plus 9 times x minus 1. And they should be the same graph. If they're not the same graph, then you've messed up somewhere. Like, for example, if you forget the 2x squared, they're not going to be the same graph. But we have a 2x squared right there. So that is our answer. Okay. Try the next ones. Now, 10's harder. If you can do 10, I'll be impressed with you. But try the next. Try 8 and 9. And 10 if you get through it. For number 8, you should have a greatest common factor of 3x. So you're going to start off by dividing everything by 3x. I was seeing a lot of you do that. That looked good. And then that's going to leave you with x squared minus 7x plus 12 there. And you can use Desmos as much as you want, but the better you know your multiplication, division, addition, subtraction, the better you will be at this. We want to break this apart, okay? So we are thinking about numbers that multiply to give us 12, but add to give us negative 7, right? So 12, you could do 1 and 12, 2 and 6, 3 and 4. None of those give you a negative number, though. So what do we need to do instead? Negative times negative, right? Negative, 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 negative. Which one of those gives us a negative 7 when we add them together? The negative 3. Negative 4. It's just a 1 in front of that x squared right there. So I'm going to have x minus 3, x minus 4 for that. And so this is your final answer. You can graph the original, graph your answer, and see if they match up, and they should. Okay? Questions there? Okay, now number 9, what's our greatest common factor? Okay, how many x's can I take out? What's your lowest number of x's that you got with a term? What? 2. You want lowest number of x's, so we're going to take out an x squared. So we got x squared that's going to be out front. And then I had 4 x's, I took 2 away, so I'm just left with 2. And then here the x's like go away all together, and I just have a 4. Okay, so this is one we just looked at. It says difference of squares. So if I am trying to do this problem, I want to multiply to get negative 4. What's my middle term on this one? What do I want to get? 0 in the middle. What numbers can I multiply together that'll give me negative 4, but give 0 when I add? What is it, Zoe? Positive 2, negative 2. It's always got to be the positive and negative of a number if you got a 0 in the middle, right? So we're going to get x squared times x plus 2, x minus 2. Would it matter if I wrote it this way, x minus 2, x plus 2? Does it matter if I switch that order? It doesn't, because it's just being multiplied. So you might write it one way, your friend might write it another, as long as your factors are the same. The things inside of your parentheses are the same. It's okay. All right, 10 is terrible because of that 12 in front. Because does 10 have a greatest common factor? It is not. So since there's no, the good thing about like 8 and 9 is they had a greatest common factor, so once you pulled it out, it was the easier factoring, right? You just had like an x squared, so it was the easier factoring. But 10, that's not going to work for us. So we've got that number in front, which makes this more difficult. So you can do X method, you could do guess and check method. Be honest, neither one of them are very easy here. Samira, did you say you got this one? How did you do it? Did you do X or did you like guess and check? Okay, so in your X, right here, what number are you trying to multiply to get? Negative 168. How'd Samara get negative 168? You got to multiply 12 by the negative 14. You multiply these together, they go here. So when you got a number in front of your x squared, you got to multiply by that number out front. Now, this is getting well beyond, one reason I don't like X methods, like those numbers are too big, right? Like, we don't know our multiplication tables up that high. I don't know my multiplication tables up that high. I do know I need to add to get 13. So you really have to go on like a guessing and checking expedition here, using the calculator more than likely, unless your mental math skills are much better than mine. So, you know, you got to start, you know, like maybe negative 168 divided by 2. Definitely works, but is negative 484 and 2 probably going to give you 13? No. So, like maybe 168. What ended up working? 8 and 21. So if I divide this by 8, I get 21. Right? So you kind of have to guess and check. Like, you know, 4 would have worked, but that would, you know, 4 and 42 is not going to give you 12. But when you try 8, like what you can do, if you really don't know, you can just start going through. You got 2, 3. That works. 4. That works. 5 does not work. 6, 7, 8. Gosh, so many numbers go into this. It's a terrible problem, really. And so I've got a positive 8 and a negative 21. But it's not going to be x plus 8, x minus 21. I've got, whenever you have a number in front of your x squared, you got to divide by that number. So negative 12, divide by 12 on both of these. You want to reduce them if they will reduce. You know, this one reduces to 2 over 3 if you divide the top and bottom by 4, or if you can't remember how to reduce fractions, you guys know how to reduce them in Desmos? If I've got 8 divided by 12, it gives you a decimal. That's not what you want. Anybody know how to change it to a fraction? Hit this little button right here. It'll change it to a fraction for you, 2/3. So if you got something you don't know how to reduce, you can always do that. We got negative 21 over 12. Both of those are divisible by 3. So we got negative 7 over 4. The x's go with the bottom, not the top. So we got 3x plus 2 and 4x minus 7. Okay, a lot of these are not that bad, like whenever you have an x squared in front. You know, they're not too awful to think of. These can be much more extensive. I do it guess and check. So I think of what numbers can multiply to give me 12. And I usually start with the ones closest together. So I probably would have started with a 3x and a 4x here. And I think, what could I multiply to get negative 14? I might try like negative 2, positive 7. If I did negative 2, positive 7, that gives me positive 21, negative 8. That would give me oh wait, my signs are wrong here, aren't they? Oh, we should get a positive 13. I did the wrong signs. You may have told me different. This should be a negative 8. This should be a positive 21. So this should be a negative 2. This should be a positive 7. I had my signs wrong over here. Because we want positive 13, so negative 8 plus 21 would give us positive 13 for that. There, and so if you check, it will work. There, so this is your answer. Those are a little tough. Even like in my calculus class, they are pretty good at doing 7, 8, or 9. They get a little stuck if I give them something like 10 right there. Because it's a lot of guess and check that's not easy to do. We only have 10 minutes left, and we've already practiced this quite a bit. So I'm